All right, so we're talking about factoring polynomials for a fella on Reddit today. So, gonna start right up here. Before you start, I want to talk about space, color, and fear. I highly recommend when you're doing any kind of complex algebra that requires a lot of space that you do it first on your own sheet of notebook paper because you're going to have a lot more space, which is going to make you more organized. It's going to make it easier to see things because you can take up as many lines as you want to. And you will have the freedom and the relaxation of working in your own space rather than being concerned with, is this clean enough for the teacher? Is this in the right order? You can make it pretty for the teacher after you do it on your own notebook. So that's space. I also like to work in color. It helps me organize things, and I highly recommend it if you take the time to do that, at least at the beginning. When you become more comfortable, of course, these things become less important. But on most worksheets, like the one in your screenshot, you don't have enough room, in my opinion, to work these accurately. Do it on your own sheet of paper and then staple it to, or just transfer the final answer over. Talk to your teacher about what kind of work they need to see. And then this final thing I want to talk about is fear, because I find when I'm teaching math, a lot of students had some kind of horrific incident with math. They got just, at some point in time, they had this, I was doing okay, and then suddenly I got like a 15 on a math test, and they never quite psychologically recover from that. The way that you get over the fear is to work these kind of problems. Look for examples on the internet that have answers on them, because that allows you to see the final answer. A lot of times now they'll step by step them for you. So if you are afraid of the math, that's going to be in the way of you doing the math accurately. So the way that you get past that is practice, practice, practice. And I'm not saying you have to come home and do 100 problems a day, but maybe do 5 or 10 a day in a free space where you're allowed to make mistakes and it's not going to impact a grade. Taking the pressure off is what I'm getting at here. So, with that out of the way, let's get into the heart of the matter here. We're factoring polynomials. Well, we can't factor a polynomial if we don't know what a polynomial is and the parts of a polynomial, so let's do that. Polynomial simply literally translates to many terms. So it's a string of constants, variables, and exponents that go together. And actually a polynomial could consist of just one of those. 25, the number 25 by itself is a single term polynomial. All right, but generally in math fields, when we're talking about polynomials, we're going to talk about long strings, and we're going to talk about that in a little bit. So what's allowed? You're going to have a constant, which is a number that stays the same no matter what else is going on within the polynomial or within the formula or whatever. A constant 3, negative 20, half, those are going to stay the same no matter what is happening with them. The second type of number that we can have is called a variable. This is a number that could change. There's a modifier attached to that. So sometimes x is 2, sometimes x is 3, sometimes x is 27, etc. It's a number that has the ability to change, whereas constants have to remain constant. And then finally we have exponents, which are, that you should be familiar with them. It's like the 2 in y to the second power, or if I said 2 to the third power, the 3 would be the exponent. In a polynomial, division by a variable is not allowed, so you would never see something like 2 divided by x. It cannot happen. It's illegal. And then they gave a definition for degree that said the largest exponent of a variable, which is accurate, but it gets a little bit more complicated when we have multiple variables and such, so don't get too hung up on that right now. That's why I put it there, but I also kind of crossed it out. Like, it's good to know, but don't think about it too much. Then we have this concept called standard form, which comes into play sometimes and sometimes doesn't, but it just simply means that you rewrite the polynomial in descending order from its highest degree to its lowest degree. So You want to bring the camera down there. See that string of numbers in black there? Thank you very much. Okay, so we're looking at the string of numbers I have in black there. And all that's happened is when I started the problem, I was given 3x to the second power minus 7 plus 4x to the third power plus x to the sixth power. And all I didn't do any math. All I did was reorganize this so that the degrees descended. So my positive x to the sixth power, with that sixth degree being the highest, went first. My next highest degree was the positive 4x to the third, then a positive 3x to the second, and then there was a negative 7 at the end. It's very helpful to do this and to know how to convert a messy problem into standard form. All right, so that takes care of the polynomial issue. Now we need to talk about the factoring issue. Factoring is the process of determining what was multiplied to reach a given quantity. And we usually want the greatest common factor. So what I did is I started with, no craziness, just a constant, the constant of 12. And its terms could be, you could have multiplied 2 by 6 to get to 12, 3 by 4, 2 by 2 by 3, which is interesting because that's the 2 times 2 times 3 is what is called prime factorization, and that's something you'll become concerned with later. For now, just throw it in the back of your brain. You could have done 24 times a half, negative 2 and negative 6, negative 2, positive 2, and negative 3, because the two negatives would cancel each other out and be multiplied by a positive. So you get negative 6, for example, times positive 2, or negative 4 times negative 3. You're going to wind up at that 12. All right. So you need to be comfortable with those ideas. Now we'll look at some actual polynomial examples. All right, so polynomial example number 1 reads 8x to the fourth power minus 4x to the third power plus 10x to the second power. So the first thing that we want to do is factor out the greatest common factor from the constants, which are 8, 4, and 10. That factor becomes 2. 2 is the largest number I could pull out of all three of those constants. Then we look at the exponents, and x to the second is the largest thing I could pull out of both of those out of all three of those exponents. So I put the 2 and the x to the second together on the outside of the parentheses, and then inside of the parentheses, I put what happens when I take that factor out of the polynomial. So if I take the 2x, or if I divided 8 by 2 and took the x to the second power away from 8x to the fourth power, I would have 4x to the second power. Moving on, from negative 4x to the third power, if I divide the 4 by 2, because I'm taking the 2 out, that gives me the 2 there. And then I would take the x to the second power away from the x to the third power. That's how I get negative 2x there. And finally, I have 10x to the second. Taking a factor of 2 out of 10 leaves us with a 5. And because the exponent is x to the second, and I'm removing x to the second as my greatest common exponent, there is no exponent to go with the 5 term. And at that point, there's nothing more. When I get down to 4x to the second, 2x, and 5, there's no common factors left, which means that I have factored that polynomial as thoroughly as it can be factored. The next example I'm going to show you has multiple variables, so we'll talk about how to do that. We have x to the third, y to the second, plus 3x to the fourth, y, plus 5x to the fifth power, y to the third power. Now, that first term, x to the third, y to the second, has no constant in front of it, so therefore our greatest constant is 1, and we don't write the 1, but we kind of understand that a 1 can come out of anything. That's why it's not written. It's a bit of a shorthand. From there, what is the largest exponent x has been raised to as we go through it? Well, we have x to the third, x to the fourth, x to the fifth. So x to the fifth is the largest, but x to the third is the largest amount that I could take out of every single term. So I'm going to put x to the third on the outside of the parentheses. I do the same process for y. I've got a y to the second, a y standing alone, and a y to the third. So the y to standing alone is going to be the highest amount I could remove from there. So I'm going to have that y join the x to the third on the outside of the parentheses, and then I'm going to write the rest of it with those removed. So in the first one, I take the x to the third and a single y from the first term, which is x to the third, y to the second. So I'm left with just a y there. I move along. I have a positive 3x to the fourth y, but I've taken 3 of those x's out and the y. So I'm left with just 3x there. And then in the final term of the polynomial, the 5 is going to stay. We didn't take any constants out. Well, we took 1 out, 1 and 5. 5 would still be left over. We take x to the third power out of x to the fifth. That's why it's x to the second. And then we took a y out, so that's why the y to the third becomes a y to the second. And let me know that should be enough to get you rolling a little bit. And if it isn't, ask me more questions. I'll make more videos. But that's what I got for you now, and this should provide a good starting place. So take it nice and easy and slow. Ask me questions if they arise. And, do your best to have fun with it, because that's really gonna, if you look at this as this giant barrier, this giant mountain to climb, you're just throwing unnecessary mental obstacles at yourself. Relax, get into the flow of it, try to enjoy it. The last thing I'll leave you with is I recommend working these in pen instead of pencil. In the American education system, we're taught to work them in pencil and then to erase and go back and fix our mistakes. I find that very messy and inconsistent. Work in permanence, meaning work in permanent ink, marker, pen, etc., and work the problems beginning to end without mistakes. If you make a mistake, simply cross it out and restart the problem. This will, over time, teach your mind to work a problem accurately from start to finish, and it will also highlight for you where in the process you make your common mistakes. That would be the point at which you have to cross the problem out and start the next one. It'll take a week or two of doing this, but after you do it, this has been described to me by my students as the single most important thing that they did to improve their grade was working in permanency, because it forces the brain to develop a process, a way of attacking these problems the same way every single time. And that's what you want to do to be successful in mathematics. Also, stay away from shortcuts. Work it out longhand until the shortcuts become obvious and comfortable to you. Have a good day, and let me know anything else I can do to help you further.